So this short video is going to look at the distributive law in algebra. This is something you may recall from last year. Let's look at what the learning goal is. What we're going to do is apply the distributive law to algebraic situations, which allows us to simplify equations and expressions. Now, as with most of the things that we're showing, or most of the skill sets we're looking at, it's all about simplifying those equations and expressions, which makes our job easier later. So the distributive law is sometimes called expanding the brackets or removing the brackets. Now, I don't like the term removing brackets because it leads to a misconception about just taking the brackets away. What we do, and I'm going to highlight some key points here, multiply every term outside by every term inside the bracket. And that's the key. If you remember that, you'll get it right every time. Only applies to terms with addition or subtraction between them, because a term such as 3xy, they're three things multiplied together, but they are an individual term, not two separate terms. So separate terms are shown by the plus and the minus signs. And remember, when we're multiplying things with negatives in the coefficient, that stays with the coefficient. So let's look at an example of the distributive law and how it works. So we're going to go back to a primary school example here and look at order of operations. Now, using order of operations, we multiply out the 2 plus 1 first, the bit in the brackets. We add it, I should say. So that's 3. This sum becomes 3 times 3, which equals 9. Now, the way the distributive law works, let's look at the same problem. What we're going to do is multiply out 3 by the 2 and the 3 by the 1. So that's the way it works. Everything inside multiplied by the 3. So we multiply the 2 by 3 and multiply the 1 by the 3. And we end up with 3 times 2 plus 3 times 1. Now that's 6 plus 3, which equals 9. The same answer. So it demonstrates that the distributive law works. So we've got 3 examples here to start off with. I've color-coded each term inside the bracket to make it easy to see what's going on. So what we're going to do is multiply that 5 outside by each thing inside the bracket. Now, these lines I've drawn in are a cue to help me remember what to do, but they're not required. In fact, when these expressions get much larger, it becomes more difficult to follow. So we're going to multiply the 5 by the x plus 5 times the positive 3. That positive goes with the 3. We end up with 5x plus 15. Here's our second example. This time we've got some negatives, so I've highlighted the x in blue. The second term, negative y, I'll take y in pink. Same as before, we're going to multiply out the 8 outside the bracket by each term inside the bracket. So 8 times x plus 8 times negative y is 8x, take 8y. So positive 8 times negative y is negative 8y. So let's have a look at the third example. This time we've got a couple negatives. Same as before, that negative outside there is linked with the a. I'm going to multiply negative a by x and negative y by negative a. So negative a times x plus negative a times negative y is negative ax, and this here should be plus ay, because negative times negative is positive. Okay, so now we're getting some more complex expressions. We'll have a look at those as well, one at a time. So for this expression, what we're going to do is the same process. So we multiply the 5x by the 6y and the 5x times the negative 7z. That's the same as we did before. So 5x times 6y plus the 5x times the negative 7z. So 5 times 6 is 30, multiplied by xy, so 30xy. 5 times negative 7, so that's positive 5, times negative 7 is negative 35, xz. So the next expression, the second from that last example, same process. Going to multiply the negative 4y by the 2x and the negative 4y multiplied by the positive 3w. So those two multiplied together, plus those two multiplied together. So negative 4 times 2 is negative 8, x, y. And remember, we usually put it in alphabetic order. Over here, negative 4 times 3 is minus 12, so that means take away 12, w times y. Okay, and the final example, what happens when you have pronumerals on the outside and the inside that are the same? Same thing, multiply the x by each of the terms inside the bracket. So x times 2x plus the x times the 3y. And don't forget, you using your index notation, when you multiply x by x, you get x squared. So that's 2 times x squared plus 3 times xy. Now let's look at some others with more complex expressions. This one actually has an extra step. So we expand the bracket and then we group our like terms. Because this is outside the bracket, we don't apply the distributive law to it. So the plus 5 is just sitting at the end. Similarly, down the bottom here, the plus 5x is here for these two. And at the front here, the 7x. This is a bit of a tricky one because the minus sign there. So let's look at those one at a time. We'll go through the same process. Multiply the 4 by the x and the 4 by the negative 4. 4 times x plus 4 times negative 4 plus the 5 on the end. Multiply that out, we get 4 times x is 4x, 4 times negative 4 is negative 16, so let's take 16, then plus 5 on the end. And now we group our like terms, so we've got negative 16 plus 5 is negative 11. Second example, same thing, use the distributive law first, multiply the x by the y and the x by the negative 2. So x times y is plus x times negative 2, that should be 2 there, plus 5x. So that should be 2x there. So x times y is xy, x times negative 2 is negative 2x. I'll write that up here like this, plus 5x. So we should end up there, xy, 5 take 2 is 3x. So xy plus 3x. We'll group the x terms. So let's look at the next one. Now we've got negatives in a few different places. Negative x times y and negative x times negative z. So negative x times y, there it's there, plus negative x times negative z. I put them in brackets. And a little note here, negative multiplied by negative is positive. And then put our plus 5x at the end. So when we multiply that out, the negative stays there. So negative times a positive is negative. X times y is xy. Plus negative times a negative is positive. So plus positive xz plus 5x on the end. Now in this case, there are no like terms, so that's the final answer. Let's just leave it there and have a look. Final answer. Next expression. Now in this case, we actually have the bracket at the end. Like so. So one way to look at this 6 here is plus negative 6. And that's a good way to think about it. Particularly when you expand the bracket there. So we apply the distributive law. That's 7x I've just thrown on the end. That's plus 7x. So it's plus 7x here. Negative 6 times y plus negative 6 times negative 2x. So negative 6 times y is negative 6y. Negative times a negative is positive, so it's plus 6 times 2 is 12x plus 7x. Now the x's here are like terms. So we're going to add them together. 12 plus 7 is 19 lots of x. So it's 19x takes 6y. And traditionally we write it in alphabetic order. That's why I've switched the order here. So from that, you should be able to apply the distributive law. Just be careful with the negative signs. That's where things will get a bit tricky. That's usually where students go wrong. Hopefully you can apply the distributive law to simplify equations and expressions, which allows us to solve more complex equations later on.